So thank you so much for having me. I wanted to take a brief moment to thank the organisers. It's really amazing to see FastFlow here for its third year. It's extended to 2 days, which I think is a big testimony to the success of team topologies, but also to the impact that platform engineering has had on our community. Now, I'm known for getting into the detail, but a keynote is usually a bit more high level, so I've decided to take us right back to basics to remind us of one of the core reasons why we do team topologies and why we do platform engineering. So without further ado, I'm Rachel Wanacott, thank you, Paula, and this is the conservation of cognitive load. So I'm going to keep this really simple. I'm going to talk you through what is cognitive load. I'll introduce the conservation principle, and then we'll give a Fidelity international case study, because I've spent a good decade of my life building various platforms at Fidelity. So firstly, what is cognitive load? Well, there is definitely a relationship between the number of tools, or the number of choices that you have to make, and your cognitive load, which is typically what we mean when we throw that term around in technology, but it is in fact an oversimplification of the original psychology. John Sweller developed the theory of cognitive load in, I think, 1988. And what he was trying to describe here is why learning something can feel really easy, but why learning something else can feel almost impossible. In his own words, the total amount of mental effort being used in the working memory. And I think it's really important that we ground our conversation around cognitive load in this particular wording, working memory. Think of it a little bit like buffers and caches. Had to get some tech in here somewhere. Hopefully a model that you're all well familiar with from your work in tech. Now, working memory is that little tiny buffer that handles new information. Long-term memory is your persistent data store. I think of mine as an S3 bucket. Probably, it's quite cheap. And the parts that you can recall instantly, your schemas are behaving like a cache. So memory that you have on hand coming into your buffer. But when you're learning something new, that teeny tiny buffer gets full really, really quickly. And once it's full, the system starts to thrash around. You probably feel really busy, but you're not actually processing anything useful, and packets start to drop, or you've lost your ideas. This is as good as my animations are going to get, by the way, so please enjoy that. So it's generally accepted that there are 3 forms of cognitive load. I'd like to throw in the caveat that as part of my research for this talk, I read John Sweller's updated research, and he's now said that there are only 2. But for the purposes of this narrative, let's stick with the 3. The first one that we have is intrinsic, which is the associate specific topic. So all the things you're thinking about when you're thinking about that topic. And I'll give an example in a moment. Extraneous is the way that that information is presented to you, or the tasks that you're required to do are presented to you. And then finally, we have the germane, which is the mental effort that is directly related to the learning process. So I typically think about that as connecting new information to your existing knowledge. Now, initially when I was reading this, I didn't really get on board with germane in terms of the narrative of my story. And because if excessive cognitive load impedes learning, isn't the category of germane load a little bit of a sneaky way of saying that that's not always the case? Fortunately, not quite. Working memory has a fixed capacity, and if the intrinsic load fills the entire available space, any additional load, whatever it might be, is going to be harmful. Think of my falling data packets, I know you love them. However, if the intrinsic load is not near the maximum, the spare capacity can be used for activities that deepen your learning. I'm going to reference that update to the paper. So more recently, Sweller suggested that germane load, rather than adding to cognitive load and being a separate piece, in fact redistributes the resources of the working memory from the non-relevant activities to the relevant ones. I do read the research. Okay, so to make this a little bit more tangible, let's talk about this in the realms of software development. If I'm a developer, the intrinsic load here is probably the language itself. So the idioms and the frameworks and the testing tools that I need to be familiar with. The extraneous load, however, is all that fiddly deployment rubbish that those platform engineers like to do. So CI/CD, YAML, Kubernetes, your secrets, that kind of gets in the way of me doing my core job, which is the germane load, or the business logic, or business value, if you may. And that's the part that creates value, or, if we're being blunt, hopefully profit. And that could be something like understanding your payment flows, or settlement rules, whatever it is that you do in your business. The aim is simple. You want to reduce the extraneous, master your intrinsic, and leave as much capacity as possible for the germane. So at this point, it's hopefully pretty obvious why we do platform engineering. Stream-aligned teams deliver the business value and want to maximize germane, and platforms are simply a way to reduce the extraneous. At this point, I don't know if Ben's in the room, I should mention it also shows up within teams. If you'd like to hear what this actually feels like for people, not the tidy academic definitions that I've provided, there's a really brilliant talk from the first Fast Flow Conf called Cognitive Overload, Bogged Down and Burnt Out. I'm not going to unpack all of this here, but it is really worth watching as it shows how load shows up emotionally and socially, not just cognitively. And once you start noticing this, you'll realize that we've sort of spent most of our careers, if you're in platform engineering, or the entirety of the industry, you could even say, dealing with cognitive load reduction. We just keep changing the rules. First came DevOps, the idea that if development and operations came closer together, we'd remove the handoffs, the confusion, and the waiting around. And for small teams, I think this absolutely did work really well. And while the term often gets conflated with the tools that we use to achieve it, if you boil it down to what it really is, Patrick Dubois, the grandfather of DevOps himself, said that it was simply about removing the friction between silos, and all the rest is engineering. Then we moved to developer experience. Now, I was really keen to get this quote up here because this is from 2012, which you might notice is significantly earlier than when developer experience became popular. And it's from a paper that was presented at the International Conference on Software and System Processes by Fagerholm and Munch. Hopefully I haven't butchered that pronunciation. And they were quite deliberate in how they defined this. Developer experience as a means for capturing how developers think and feel about their activities within their working environments. But more importantly, on the premise that that will show an improvement of the impacts to both the characteristics of a sustained team, but also sustained projects. So there was an assumption in there. And finally, here we are, very much in the era of platform engineering, which seeks to solve all of your cognitive load problems. And I admit that that is deliberately a little bit hyperbolic, but I don't think it's unfair to say that's a characteristic of how people typically talk about platform engineering. The problem, of course, is that complexity doesn't really go away, it just moves. The vocabulary changes, DevOps, developer experience, platform engineering, but the pattern is somewhat the same. And if complexity is moving, the real question for me is then, where did it go? So I'm actually a physicist, and I would argue that we are also empirical. Engineering is an abstraction on top of physics. Dave, I can't see you, but that's a nod to you. I was an astrophysicist in a previous career. And I want to do a little GCSE physics lesson. So this is the conservation of energy on screen. As this cart on the roller coaster is at the top of that mound, it has peak potential energy. As it rushes down the slope, it's gaining kinetic energy. For completeness, when it's halfway up, it's a combination of potential energy and kinetic energy. But the key thing to understand here is that if this is a closed system, the total energy remains the same. And from what I've observed in platform engineering, cognitive load, or complexity, behaves quite a lot like this. It can't be destroyed, it can only be redistributed. Now, that idea is somewhat uncomfortable, right? Because we've spent years selling platform engineering as a way to remove cognitive load, and I'm saying that it's always there. And that's because we're looking at it through the lens of the developer. When we simplify something for one group, we almost always move the complexity to another. And in the case of platform engineering, that's towards the platform team. Build a self-service platform, and you reduce the developer load. Fantastic. But now the platform is carrying that complexity. Abstract the platform again, the complexity still doesn't disappear, it just moves further downstream into the infrastructure. In our own case, so Fidelity, our Kubernetes platform is absorbing that load from the developers, but we ourselves are in fact an abstraction on top of our AWS Ops platform that abstracts some of those AWS services away from us. Someone is always paying the complexity cost. The law of the conservation of energy says that the total energy in a closed system remains constant. And so, could I perhaps rephrase my own law of the conservation of cognitive load as the total complexity in an organization remains constant? I'm posing this as a hypothesis, see, we're empirical. So, mature platform engineering is not about removing cognitive load, it's about managing where you place it. I did promise Paul I wouldn't do this, but I'm going ahead. So, back in 2022, Paula Kennedy asked a brilliantly simple question at PlatformCon by saying, whose cognitive load is it anyway? And she was right to ask. We rarely actually stop to talk about the impact that the cognitive load has on the platform team, although it is the foundations of team topologies, so you'll see where I'm going with this. The promise of platform engineering is to make life simpler for the developers, but inside the platform team, the simplicity actually translates into orchestration, integration, and constant decision-making. Every abstraction that we add, every guardrail, every golden path and automation is something that we have to design, something that we have to test, something we have to maintain, and something that we need to evolve. So the question for me becomes, how do you build a platform that can carry that weight without breaking? It's a good point in this journey to bring in my own time at Fidelity. So this is the case study that I was talking about. And I've presented at a few conferences, actually, about our migrations from Cloud Foundry to Kubernetes. And it's something that people keep wanting to hear about, so forgive me for using this once again. If we go back to my initial timeline, DevOps, DevX, platform engineering, what I neglected to mention was PaaS, or Platform as a Service, which predates the term platform engineering, but really had many of the same goals. Now, what made these platforms, and I typically talk about Cloud Foundry because it's the most well-known and possibly the most successful, or at least in the financial services industry where I work, was that it was, even if it hadn't been coined yet, a thinnest, viable platform. Cloud Foundry was, in fact, intentionally very opinionated, and that is kind of the point of a thin, viable platform, and that's what reduces the cognitive load for, you guessed it, the platform engineers. There's always going to be an intrinsic limit to how many services a single platform can successfully operate without breaching that cognitive load limit. So the question is then, what is the smallest number of services that makes that platform viable? And what happens when that number is still too high for your cognitive load? Bit of a problem, isn't it? So when we think about Cloud Foundry, we think about the model that we used. We had a single platform team, and that worked really well when our acceptance criteria for that platform was particularly discrete, and the platform was very opinionated. And what we learned on the journey is that Kubernetes is significantly more complex, and significantly more complex in the platform engineering sphere. And so we couldn't scale that single team model. What you see on screen is a little architecture diagram. It's quite old now. Our stack is significantly more complicated than you see here, but it serves a purpose. The sheer scale of the CN/CF add-ons that we're using at Fidelity. The boxes in orange show you the parts that are managed by AWS EKS, which is mostly the control plane. And that's our first layer of abstraction when we're talking about cognitive load. So yes, adopting EKS has reduced the intrinsic load that we need to run our Kubernetes platform. But you'll notice that EKS is not really an off-the-shelf product like Cloud Foundry might have been considered. even if that's what management thought that it would be. And with Cloud Foundry, you could simply CF push everything. So you didn't even really get that involved with the deployment process. High abstraction, low choice, low cognitive load. Kubernetes gives you flexibility, but with that comes complexity. So every blue box in that diagram is something that my team is having to manage. And you'll notice that many of these things are products in their own right, that have their own life cycle, that have change upstream. So there's lots of different products that we have to think about. That's increasing our intrinsic load. But from an extraneous perspective, unlike something like AWS or Azure that has a service catalog that have been built to complement one another and have similar interfaces, most of these products weren't really built with each other in mind. They were built in isolation. And so there's quite a lot of extraneous load when we're figuring out how to build these together. So what happens then when we start hitting the platform cognitive limit? So after PaaS, our first foray into platform engineering was our AWS operations team. And our product here was essentially a private mini data center per workload team. What that looked like at the back end was the automated provisioning of an AWS account for each team. We handled all of their back-end services for them out of the box. Your really rudimentary networking, really, more than anything else. Things like your DNS, things like your proxy. We built your transit gateways. You didn't need to think about any of the fun stuff. Complexity crept in when we started building an SD-WAN, when we enabled Windows alongside Linux, and began automating our image bakery. At that point, we were hitting our own cognitive limit. We were a team of maybe 6 to 8 people. You could start to see the team smells, like code smells, long-running pairs becoming siloed SMEs, frustration showing up in retrospectives, and people generally hesitating to be on call because they didn't feel like they were across everything. We fixed it by turning these products into individual services and co-building them with teams who would own them later. So that was a deliberate collaboration mode, to use the TT vernacular, and then we made a handover and they were run as products themselves with X as a service. That reduced both our operational, but specifically our extraneous load. Kubernetes, though, as you know, is a different beast, a much higher intrinsic complexity plus the churn of open source, although I do love it. Our goal was to abstract as much cognitive load as possible from the developers, but the thinnest viable platform that achieves this is already too much for our single team to operate. So what we've actually done is move towards a platform group, which you might be familiar with from the second revision of the book, Team Topologies. Essentially, multiple domain platform teams, so CI/CD, observability, security, databases, however you want to chunk it up for your org, are working behind consistent interfaces that are presented as a single platform. It's a little bit ambitious. If you think about Amazon, it does this at scale, but with significantly more people than my 12-person team. But our aim is a curated service catalog. I wanted to get this in here to show you how we've modeled some of those team interaction modes and the evolution of how we're essentially using our organizational structure to enable us to have less friction and have faster flow. Hopefully you're familiar with this from the book by now. It's been out for some time. But essentially, we're choosing when to be in collaboration mode, typically for a short defined period of time when we need to learn, and then we move things towards X as a service. The main thing here really is to have very clean-cut definitions of who is responsible for what. The enablement group is very similar to the platform group, and I've called out some of the key pieces there. Okay, this is my last slide, and I've called this the sourdough playbook, and it's hot off the press. As we've scaled, we've also had to handle a variety of different workloads, not just the business application workloads that we originally set out to host. Infrastructure teams, who wouldn't typically be running on our application platform, also now want to run there. Beyond the obvious challenges of things like blast radius to your platform or cyclical deployment dependencies, which I won't speak about here, running bespoke infrastructure services demands more specialist domain knowledge, which increases our intrinsic load. And switching between inconsistent tools and contexts dries up the extraneous load. So we can reduce the blast radius and those chicken and egg dependencies by starting to split things out. But we need to do this while maintaining our culture and our consistency and having that consistent service offering. So I'm splitting my team into sourdough starters. So some of the core team will bring their culture and their knowledge into the new team. I will then supplement the sourdough with some flour, which will be some individuals from the organization who want some career vitality, so this is good for them. And we might also bring in some professional services if we're under some time pressure. The idea is simple. You take a piece of the original culture, the proven engineering practices, standards and tooling, and use it to seed new self-sustaining teams. So cognitive load can't be destroyed, but it can be designed. You'll notice that I haven't given you a playbook or a takeaway slide to take away with you, and that's deliberate. You need to think about your individual organization, your unique culture, your unique tools. What is your business? And figure out how to redistribute your own cognitive load. Thank you very much. I've been Rachel Wonnacott, and I'm so pleased to be here. Thank you very much.